Hello students. In today's lecture we are going to discuss about how do metals and non-metals react. So this is a very important topic, and here you are going to learn how they are going to behave. So what is the property of these metals and non-metals? So basically all elements, they want to become stable like noble gases, which have completely filled outermost shells. This you already know. So this is called, so this rule is known as octet rule, right? So elements, they try to achieve 8 electrons in their outermost shell. So then they will become more stable. So all the elements will try to get that octet configuration to their outermost shell also. So let us take an example. Now we discuss about the sodium. So what is the atomic number for the sodium? For the sodium, atomic number is 11. So if you write the electronic configuration, it will show 2s2, 1s2, 2s2, 2p6 and 3s1. Is it not? So how in the first shell 2 electrons are there, second shell 8 electrons are there, in the third shell only 1 electron is there. So outermost shell, in the M shell you can find only 1 electron. So to become stable, what it will do is it will try to lose its one outermost electron, and after losing it, sodium becomes Na plus, is it not? Whenever electron is lost, it will become positive ion, and that sodium becomes cation, and this configuration becomes 1s2, 2s2, 2p6. That means in the outermost shell you are having 8 electrons for the sodium. So it is achieving its octet configuration. Similarly, if you go to chlorine, so for chlorine, what is the atomic number? Chlorine, the atomic number is 17. So what is the electronic configuration? If you observe, 1s2, 2s2, 2p6. Then in the outermost shell, 3s2, 3p5. So like this the configuration is there. So if you observe, how many electrons are there in the outermost shell? 7 electrons are there. So if it can gain 1 electron from some external force, it can complete its octet. So what chlorine will try to do? It will try to gain 1 electron and becomes chlorine Cl minus, and this chloride ion, chloride anion, and its configuration will become 288. That means 1s2, 2s2, 2p6, 3s2, 3p6. Then it will be stabilized. So now we discuss which type of bondings they are going to form. So here in this table, electronic configurations of some of the elements are shown clearly. If you observe noble gases, helium, neon, argon, krypton, so these all are noble gases. For the for example, for helium atomic number is 2, for neon atomic number is 10, for argon atomic number is 18. So if you observe, the shell numbers are given K, L, M, N like this. So first, for helium the atomic number is 2, so the first shell is filled with 2 electrons. So very stable atom. So it is having 1s2. Coming to neon, it is having octet rule is satisfied here. So 10 means 1s2, 2s2, 2p6. So in the outer shell, second shell, that is L shell, it is having 8 electrons. Coming to argon, 18 is its atomic number. So first shell 1s2, second shell 2s2, 2p6, and third shell 3s2, 3p6. That is the configuration. So the outermost shell is again satisfying the octet rule. So these all are known as inert gases. They are not at all interested in any reaction. They are most stable in their nature. Coming to metals, sodium, magnesium, aluminium, potassium, calcium. One by one we will see. For sodium, the atomic number is 11. So we observed that 1s2, 2s2, 2p6, 3s1. Only 1 electron is there in the outermost shell, and sodium tries to lose its electron and it will try to become Na plus to get the stability. Similarly, magnesium, its atomic number is 12. So you will get one more compared to this, it is one more electron is there. So 3s2 will be there for this one. Coming to aluminium, 3s2 3p1, is it not? Potassium, so potassium, the atomic number is 19. So 1s2 2s2 2p6 3s2 3p6 and 4s1, one electron is there. This will be it also tries to lose its electron because only one electron is there. For calcium, the atomic number is 20. So you can find two outermost electrons for the calcium. Valency is 2. For potassium, valency is 1. For aluminium, valency is 3. Magnesium, valency is 2. And sodium, valency is 1. Like that you can check. Coming to non-metals. For the non-metals, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. So if you observe for nitrogen, the atomic number is 7. So it is having 1s2 2s2 2p 2s2 2p3, is it not? So in 5 electrons are there, right? 2s2 2p3, right? 5 electrons. So what is the tendency of this one? You observe. For oxygen, the atomic number is 8. So 2s2 2p4 it will become. For fluorine, 9 electrons are there. So 2 electrons in the first shell and 7 electrons in the second shell. So like this the configurations are differing. So if you observe, outermost shell 5 electrons, 6 electrons, 7 electrons, like that. So that is nearer to 8. So what is the tendency of the non-metals? They try to gain one electron to get the octet configuration. And coming to metals, they try to lose its electron to get the octet configuration. And if it is a noble gas, they are already stable. They are in the octet configuration itself. So it is clearly mentioned over here. If you observe, sodium will try to lose its electron and it is forming a sodium ion, right? And similarly chlorine is trying to gain an electron to get the octet configuration and it is becoming chloride anion, and sodium is cation. Sodium is a positive ion and chloride is a negative ion. So now how they are getting this configuration is they both will come into a bonding. This type of bonding is known as ionic bonding. So ions are getting formed. One electron, sodium is losing its electron and that electron is gained by chlorine, and this type of bonding is known as a ionic bonding, formation of sodium chloride. Similarly, if you observe magnesium and what about magnesium? For magnesium, valency is 2. So it will try to lose its 2 electrons to get the octet configuration, is it not? So magnesium will lose its 2 electrons to form magnesium as a cation, and chlorine, actually one chlorine need only 1 electron. So now how bonding will be formed is 2 chlorine atoms will come into picture. Each chlorine will gain 1 electron from magnesium because it is having 2 free electrons. So magnesium is losing its 2 electrons and it is giving them to chlorine, 2 chlorine atoms. So that's why MgCl2 that is getting formed. So Mg is losing its 2 electrons. So Mg2 plus you are showing, and chlorine is gaining 1 electron. Each chlorine is gaining 1 electron, Cl minus, like that. How many chlorines are there? 2 chlorines are there. So this is also example of the ionic bond.